applying this to, first of all, the brown bag, the red bag, for an upper control limit for ranges based on samples of size 5, which is the kind of ranges that we worked with in that demonstration. What I need is to take big D2 times sigma. Big D2 for a sample of size 5 is 4.918, and then I multiply by the standard 1.715, the given sigma, and that turns out to be 8.43. If you look in the table on page 509 and try to find a lower control limit for ranges, you'll find that there's nothing there. And the reason for that is that for small sample sizes, big D2 minus 3 times big D3 turns out to be negative. It doesn't make any sense to announce a negative control limit for ranges, and so there simply is no lower control limit used for that case. If you take this number and go back and see what there is to see in these ranges, I've drawn in 8.43 as an upper control limit there, and you can see that the first 15 samples that did come from the red bag, did come from the brown bag, do not produce ranges outside of that control limit for R. When you get to sample number 16, there's an R that plots outside of limits. And so the thing that's to be learned there is that if this had been applied in real time, and I mean as the ranges come rolling in, as opposed to applying this limit retrospectively, we would have detected change from sigma of 1.715 at sample 16. If we wanted to think about retrospective analysis of the data from fall 2001, I'll recall for you that 18 sample ranges have an average that is 4.278, and therefore a retrospective upper control limit for R is, well, we'll take this 4.278 and multiply it by big D4, and big D4 for samples of size 5, the table lists that as 2.115. When all is said and done, that is 9.05. And if you look back at the ranges in this example, range at time 16 is 14, and even throwing together samples from both the red bag or brown bag process and from another process, we still would detect at time, we would detect that there has been process change across these 18 samples. So the point here is that we have evidence of process change or process instability in these 18 ranges. Okay, so those X-bar charts, R charts, are the two most common Shewhart control charts. Justifiably so for X-bar charts. R charts have got historical momentum that causes them to be used when in fact a better alternative is to use not ranges but sample standard deviations.